Welcome to my channel. Looking back at my previous scripts, I remembered that I originally planned to make an induction door simulation. But as they say, man proposes, God disposes. While checking the delivery status of my online order, I got completely captivated by the MDS display. So, I started researching expandable LED panels. Unfortunately, I have to switch simulators again. Given how limited my resources are at the moment, I should probably just be grateful that there's any usable simulator at all. Let me first talk a bit about the process of researching LED panels. I never thought LED panels needed much research. They should be pretty simple, right? After all, back when I was working on video game projects, I used to calculate and render dynamic pixel graphics myself. But after seeing the MDS display demo, I started thinking about making my own LED panel to use temporarily until I can get my hands on modular lights. Before getting the hardware, I decided to do some prep work, like figuring out what changes would be needed in the code once the LED strips are assembled. Luckily, I found a fairly recent demo on YouTube. The channel creator used 8x8 LED panels extended to the right to create a marquee effect. After understanding how it all works, I realized that the LEDs on the panel are quite different from the single LEDs that beginners usually work with. If you want to create a signal light strip using individual LEDs that can be controlled in sequence, you'd need a dedicated control chip. That's also when I learned the difference between addressable and unaddressable LED strips. In the example I referred to this time, the LED panel only uses 3 wires. This is probably the latest and most commonly used version. Panels with only power wires obviously can't be controlled, so I didn't include them here. When there are too many pins, it becomes harder for a design to gain popularity. As we saw in earlier LCD examples, designs with too many pins aren't well received. It's the same reason I don't want to use an Arduino as the LED control chip. I'd rather just buy LED strips that already have built-in control chips. A project isn't meant to control just a single component. Only QA, quality assurance, does that kind of thing. When I first started looking into full-color LEDs, the name WS2812 came up early on. After using this new simulator, WACWI, I was surprised to find that WS2812 is actually considered valuable enough to be included as a simulated component. With so many new components being released these days, simulators don't have the luxury of spending tons of development effort simulating parts that aren't worth it. But the WS2812 addressable LED is worth that effort. And for me, discovering a component with real value is also a valuable learning experience. After finishing my research, I plan to test it in the simulator, only to find that Tinkercad doesn't even have LED matrix. After studying how to build an LED control circuit, I decided, better not to go that route. So I looked around to see if there was a usable simulator. Ordering online takes a long time, especially since I haven't even placed the order yet. My very first order has already been pending for almost a month. Fortunately, I found WACWI, the simulator shown in the videos so far. Since I often need to work with niche components, finding something usable feels like a blessing. I'm truly grateful to the heavens, and to the amazing people who created these tools. Like the Blender team, for example. Because what I'm testing is a LED matrix with the pin design that matches the WS2812, I didn't use a 5-pin LED matrix in the example. Instead, I used individual WS2812 components. I started by testing with an LED strip. Just the fact that it supports the library I need for working with LED matrices already makes it impressive. And it even allows you to upload your own libraries, though that feature is part of the paid version. If I end up needing that functionality, I'd be willing to pay for it. Honestly, the most exhausting thing is not being able to find the right tools. While WACWI is powerful on the programming side, the circuit UI can be a bit tedious. But it's not a big deal. The UI is controlled by a .json file, so once the key components are placed, it's actually easier to just edit the JSON directly. I added the rotate parameter to adjust the orientation of VCC and GND. After wiring up 2 WS2812 LEDs, I duplicated and repositioned them by editing the JSON file instead of dragging them manually. The circuit editor's grid alignment isn't very precise, so it's better to first confirm a workable layout and then fine-tune it via the JSON file. That way, you can avoid crashes caused by UI glitches. After finishing the circuit diagram, I tested the library upload feature. I downloaded the most commonly used LED matrix library from Adafruit, since they're the standard provider. Then I found out that uploading libraries is a paid feature, haha. So instead, I added the library I needed to the project using the search function. Even though the added library doesn't automatically show up in the code, I'm just grateful that it works at all. Then I started writing the code. Currently, my LED strip is connected to Arduino's D7 pin, and I'm using 8 LEDs. The library I'm using to control the LED strip is addressable. The third parameter of the constructor can be found in the .h file. For now, I've just copied the settings from an example I found. In the setup function, I only wrote the pin configuration for the Arduino and initialized the addressable object. In the loop, I first clear the LED strip's color settings. The interface suggested using the bit clear function, but I wasn't sure if that was the correct one, since it looked different from the examples I had. So I checked addressable.h and confirmed that it only has a clear function. For this test, I plan to show a moving light effect like a color running forward along the strip. To do that, I need to create an array to store the colors of each LED. I looked into how the addressable object stores color data and found that the type is uint32_t. In the loop, I use a for loop to copy the color from the previous LED to the current one. At first, I thought I could do it in forward order, but obviously that overwrote the data I still needed. So I changed the loop to go in reverse. After starting the test, I realized that breakpoints on Arduino don't seem to work in the simulator. No colors appeared on the LEDs. Then, due to a lack of proper logging and doing too many dumb things while trying to debug, I stopped recording the session. The reason no colors showed up was, in hindsight, a really silly one. I forgot to call the show function. By the time I found the issue, I had already set up a basic version of debug messages and a string buffer. On the bright side, now I know that debug messages for future projects won't be a problem. It's been a long time since I last wrote in C. Personally, I find it more satisfying to use a for loop to print a uint array in debug messages. But after years of working with others and writing in various programming languages, I've come to realize that making your code readable is far more important. That's it for the simulation example. See you in the next video.